Hello, good morning to all of you. Okay? So, pasok tayo sa part 3 ng ating syllabus, no? Ito yung tinatawag na work, energy, and power. So, sa libro natin na ang author ay si Catnell, this is chapter number 6. Okay? So, itong chapter na to is composed of 9 subtopics, no? So, andyan si work done by a constant force, the work energy theorem and kinetic energy, si gravitational potential energy, si conservative versus conservative forces, the conservation of mechanical energy, neoconservative forces and the work energy theorem, power, other form of energy and conservation of energy, and yung last topic is work done by a variable force. Yun. Okay? So, mag-start tayo dito sa work done by a constant force. Okay? So, work is a familiar concept. So, very familiar na tayo sa tinatawag na trabaho or work, no? So, work is for example, it takes work to push a stalled car, no? In fact, more work is done when the pushing force is greater or when the displacement of the car is greater. Okay? So, force and displacement are in fact the two essential element of work. So, makikita natin dito sa figure na to, yung nagtutulak na tao, no? Na yung pushing force or yung F, that points in the same direction as the resulting displacement S. Okay? So, kung yung tao daw ay nagtulak papunta sa kanan, okay? Kung yung tao is nagtulak papunta dito sa kanan, ang resultant natin is papunta rin sa kanan. Okay? So, in such a case, the work W is defined as the magnitude of F of the force times the magnitude of S or the displacement. So dito makakapag-formulate tayo ng work is equal to Fs or yung work equals to the force multiplied by the displacement. Okay? So the work done to push a car is the same whenever the car is moved north, south, east, or west. So, provided the amount of force used in this distance move are the same. So, since work does not convey directional information in a scalar quantity. Okay? So, yung equation na W equals to Fs indicate that the unit of work is the unit of force times the unit of distance. O ito yung tinatawag natin na Newton. Yan. Okay? Newton meter. Okay. Di lang pala Newton. Newton meter. Ayan. So, itong unit na to, na Newton meter, is nakapasok to sa SI unit. Okay? So, 1 Newton meter, so this is the conversion, no? 1 Newton meter is equivalent ngayon sa 1 joule. Okay? So, ibig sabihin, 1 Newton meter is equal to 1 joule. So, yung joule na to is ibinigay na unit galing kay James Joule na nabuhay ng 1918 hanggang 1889. So, siya kasi yung nag-research ng nature of work, energy, and heat. Okay? So, with the definition of W or work equals to force multiplied by the displacement, have the surprising features. Okay? If the distance is zero, the work is zero then. Okay? Even if a force is applied, so So, paano yun? Ibig sabihin daw, kunwari, um, kapag nagtulak tayo ng sasakyan and hindi siya na-move, ibig sabihin kahit nagbigay tayo ng energy, kung walang na-move na sasakyan, wala ding work. Okay? So, pushing on an immovable object size a brick wall may tear your muscle. Okay? So, pag itinutulak natin yung solidong pader, nagkokos ito ng hirap sa ating mga muscle. Pero, walang work na napupuntahan. Okay? Kasi wala tayong displacement. So, in physics, the idea of work is intimately tied up with the idea of motion. So, if the object does not move, the force acting on the object does not work. Okay. So, kung walang gumalaw dyan, wala ding magwo-work. Okay. Okay? So, ito naman, table 6.1, ito yung unit of measurement of work. Bali, ito yung pinag-aralan ni James Joules. Okay? So, sa SI, meron tayong Newton, multiply meter by meter equals to joules. Sa CGS naman, dyne, multiply by centimeter, magiging erg. Paki-check na lang kung tama yung pronunciation ko niya ng ERG. ERG. So, sa British English naman is pound, multiply by foot, magiging foot-pound. Okay? So, yun. So, ano nga ba yung definition ng work, definition of work done by a constant force? So, sabi dito, the work done on an object by a constant force F is work multiplied by the F cosine theta S. Okay? Where the F is the magnitude of the force, S is, yung S naman is yung magnitude of displacement and the theta naman is the angle between the force and the displacement. Oh, and ulitin ko dito is SI unit nito is Newton meter joule. Okay? So, meron tayong example number 1. Okay? So, sabi niya dito, find the work done by a 4.0 Newton force in falling suitcase na makikita natin dito sa figure na to. So, at an angle of 50 degrees for the distance of 75 meters. So, paano natin siya i-approach? Okay? So, madali lang to. Okay? So, sabi niya, meron daw tayo na 40 Newton force, tapos 50 angle. O, direct substitution lang to. Okay? So, the falling force caused the suitcase to move the distance of 75 meter and thus work. So, however, the force makes an angle of 50 degrees with the displacement, no? We must take angle into account by using definition of work na binigay dun sa equation. Okay? So, the work done by a 45 Newton force is, gamitin natin yung formula nyo, W equals to F cosine theta multiply ito ng S. Okay? Ano yung force natin? Yung force natin is 45. So, magiging 45 cosine 50. Multiply natin to ng 75. And this is the direct substitution problem lang, no? Okay? So, using our calculator, no? 45 cosine 50 multiply by 75. So, ang lalabas dito is 2,169. 2,169 joule, or approximately this is 2,170 joules, and this is our final answer. So, palit lang muna ako ng board, no? Wait lang guys, palit lang ako ng board. Mas gusto ko yung isa kong blackboard, si Inkudo. Ayan. So, palit lang ako ng notebook. Punta tayo sa Physics for Engineers. Ayan. Mas gusto ko dito. Ayan. So, balik tayo sa presentation. So, nakuha na natin yan. Example number 2 tayo ngayon. So, dito naman sa example number 2, no? So, the weightlifter, yung nagbubuhat ng mga mabibigat na bagay na makikita natin dito sa figure na to, no? Is bench pressing a barbell. So, those weight is 710 Newton. Yung weight na yun, no? So, in part B of the figure, itong figure nyo to, he raised the barbell at a distance of 0.65 meters above the chest. And in that part C, he lowers in the same distance. So, the weight is raised and lowered at a constant velocity. So, determine the work done on the barbell by the weightlifter using a lifting pace and the lowering pace. So, paano natin siya i-approach? Okay? So, para makalculate natin to, this is necessary to know the force exerted by the weightlifter. Okay? So, the barbell is raised and lowered at a constant velocity. Therefore, meron tayong tinatawag na equilibrium. Okay? So, consequently, the force F exerted by the weightlifter must balance the weight of the barbell. So, kung ano yung weight ng barbell, yun din yung force na i-exert ng weightlifter. Okay? So, pwede nating sabihin na yung F na yun, is equal ngayon sa 710 Newton. Okay? So, during the lifting phase of the force F and the displacement na S, they're in same direction. Okay? Baba, taas lang. So, the angle between is 0 degrees. Okay? Yung theta natin ngayon is 0. Ayan. So, when the barbell is lowered, however, the force and displacement are opposite in direction. Okay? So, the angle between the forces and the displacement is now, ito 180 na. Kasi tumaas, bumaba. Okay? So, with this observation, we can find the work, no? So, gamitin natin yung formula na F work is equal to F cosine theta. This is multiplied by S. Okay? So, during the lifting phase, no, the work done by the force F is given by this equation. So, mapapasok ngayon. So, pasok tayo sa letter A. W is equal to the force. Yung force natin ngayon is yung 710 Newton. And cosine, 0. Okay? Multiply natin to ngayon ng 0.65 meters yung pag-angat niya. Okay? So, calculator muna tayo. Mangyayari dito ay 710 cosine 0 multiply by 0.65. And ang sagot dito is 461.5. This is Newton meter. Okay? Or Joule. Okay? This is Joule. Op. Ayan. So, letter B naman tayo. No? Yung work naman natin dito is halos parehas lang. Papalitan lang natin ng 180 to. Okay? 710 Newton cosine 180 degrees multiply by 0.65 meters. Okay? So, papalitan ko lang to ng 180. So, ngayon, lumabas is negative na. Okay? So, negative 461.5 joules. So, since cosine 180 is negative 1, the work is negative because of the force is opposite to the displacement. Okay? So, weightlifter call each complete up and down movement of the barbell a repetition or reps. Okay? Yung pag-akyat at baba daw ng barbell is yung tinatawag nilang reps or repetition. So, the lifting of the weight is referred as the positive part of the rep and the lowering is the negative part. So, 'di ba pag mapapansin nyo pag inaangat natin yung barbell, ang laki ng force na ginagamit natin kasi dahil sa gravity, no? Medyo masakit sa kamay. Pero pag ibababa na natin yung barbell, is medyo relax na. Okay? Kasi negative na yung force na ini-exert natin. Yung bumababa na lang doon sa barbell is yung tinatawag na gravity. Okay? So, yun siya. Kaya to, negative. So, balik tayo sa presentation. So, meron pa tayong example number 3. Ayan. So, dito naman, kung makikita natin tong figure na to, meron daw 120 kilogram crate na naka-flatbed sa truck na nagmo-move with an acceleration of positive 1.5 meter per second squared along the positive x-axis. So, the crate that does not slip. So, ibig sabihin, hindi daw dumudulas with respect to the truck. Undergoes a displacement whose magnitude is S equal to 75 meter. So, what is the total work done on the crate by all the forces acting on it? Okay. So, mapapansin natin dito sa figure na to, ito yung mga forces, no? So, ito yung tinatawag nating free body diagram. Okay? This is example number 3. Ayan. So, the free body diagram na pinakita ko sa inyo shows that the act of the crate, no? So, number 1, yung weight ng, maganda is i-drawing natin ulit siya dito. Okay? So, una na mag-a-act sa kanya is yung weight ng crate. Tapos, ito naman yung tinatawag na normal force. Okay? Ito yung ibinibigay na force ng flatbed para hindi mahulog or hindi umilalim yung ating crate. Tapos, meron tayong tinatawag na frictional force na Fs. Okay? Ayan. Frictional force na Fs. So, which is exerted by the flatbed in the forward direction and keeps the crate from slipping backward. Okay? So, yung weight and the normal force are perpendicular to the displacement. So, they do not work. Okay? Only the static frictional force does work since it acts on x direction. Okay, nasa x direction siya. No? This is x and this is y. Ayan. So, to determine the frictional force, we note that the crate that does slip and therefore must have the same acceleration of 1.5 meter per second squared as does the track. So, the force creating the acceleration is the static frictional force. And knowing that the mass of the crate and its acceleration, we can use the Newton's second law of motion to obtain its magnitude. Then, knowing the frictional force and the displacement, we can determine the total work done on the crate. Okay? So, ang mangyayari dito, meron tayong tinatawag na formula ng Newton's second law na F of S is equal to MA. Okay? So, galing to sa formula na force equals to mass multiply by the acceleration. So, meron kaming kalukuhan nun dito, no? Para mas mabilis na, ano to, para mas mabilis na matandaan, no? Kasi yung M daw, pwede mong ibaba dito. Matitira is A doon. So, magiging F. F over M equals to A. So, father over mother equals, bahala na kayo. Okay. So, balik tayo sa formula. So, yung Fs natin is equal to 120 kilogram. 1.5 meter per second square. So, okay. By mental calculation, ang lalabas dito is 180 Newton. Ayan. So, the total work is done with the static frictional force, no? So, papasok pa rin tayo dun sa formula na W equals to Fs cosine theta. Okay? Yung theta natin is 0. So, multiply natin to ng S. So, mangyayari dito is 180 cosine 0 multiply by 65 meters. So, yung cosine 0 automatically magiging 0 angle yon. 180 cosine 0 times 65. And this is 11,000. 11,700 joules. Or approximately, pwede natin ito na sabihin na 1.2 times 10 raised to 4 joules. And this is our final answer. Okay? So, pasok tayo sa topic number 2. Ito yung tinatawag na the work energy theorem and kinetic energy. Okay? So, most people expect that if you do work, you get something as a result. Okay? So, kapag may tinatrabaho ka, ibig sabihin, meron kang outcome sa pagdating sa dulo. Okay? So, dito naman sa physics, when a net force performs work on an object, there is always a result from the effort. The result is a change in kinetic energy of the object. So, as we will know, so meron tayong relationship na nagre-relate sa work to the change in kinetic energy. Okay? Ito yung tinatawag nating work energy theorem. Okay. This theorem is obtained by bringing together three basic concepts that we have already learned about, no? Yung first, yung apply the Newton's second law of motion na force is equals to mass times up acceleration, which relates the net force na F, no, to the acceleration A of an object. When we'll determine the work done by net force when the object moves through a certain distance. Finally, we'll use equation na anong equation yung mamaya? One of the equation of kinematics to relate distance and acceleration to the initial and final speed of the object. The result of this approach will be the work energy theorem. Okay. So, to gain some insight into the idea of kinetic energy and the work energy theorem, so let's see this figure here, no? Where constant net external force F, okay? Meron siyang constant force F acts an airplane of the mass M. Okay. This net force is the vector sum of all external forces acting on the plane. And for simplicity, it is assumed to have one direction of the displacement na tinatawag nating S. Okay? According to the Newton's second law, the net force produce an acceleration A given by the A equals to F over M. Okay? So the speed of the plane changes from initial value of initial velocity to the final value of final velocity. So multiplying both sides of summation of A multiply by MA for the distance gives, punta tayo kay Kudo. Okay? So di ba meron tayong F. No, F equals to MA. Or sabihin natin summation of F, no? Equals to MA. Ngayon, i-multiply natin to, no? Ng both side. So, parang magiging ganito siya. F multiply by S equals to M A S. Multiply natin ng S both side, no? So, ito yung tinatawag nating work done by the net external force. Okay? So, itong left side ng equation na to, ito yung tinatawag na, yun nga, yung work done by net external force. So, the term AS on the right side naman, ito daw AS na to, can be relate sa BO and BF or yung initial and final velocity using yung formula natin nung nakaraan na final velocity squared is equal to initial velocity square plus 2AS. Uy, lumabas yung AS dito, lumabas yung AS doon. No? So, solving the equation, so magiging AS is equal to 1/2. No? Final velocity square minus the initial velocity square. Yan. So, pag sinubstitute natin, yung pag sinubstitute natin, yung summation of AFS, ito, no? Equals to mass. Ang lalabas dito, di ba may AS? So, itong M na to is bababa. Tama ba? Or pwede natin ipasok lahat. So, ang lalabas dyan, F is summation of S of F multiplied by S is equal to 1 half m, the final velocity, square minus 1 half m, initial velocity, square. So this is expression is work energy theorem. Okay? Its left side is the work done by an external force. Okay, itong left side na to. So yung right side naman is involves the difference between the two terms. Each uh, each of which has the form of 1 half mass multiplied by the squared of speed, no? So the quantity 1 half mass speed square is called the kinetic energy. Oh, ito na yung tinatawag nating kinetic energy. And plays a significant role in physics as we will see the chapter na nagpapakita nung kinetic energy na yun. Okay? So, what is the definition of kinetic energy? So, the kinetic energy or KE of an object with a mass m and a speed of v is given by KE or kinetic energy equals to 1 half mv squared. Okay? So, ang unit nito is joule. And ang definition naman ng work energy theorem, so when the net external force W on the object, the kinetic energy of the object changes from initial value to KE0 to final value of KEF. So the difference between the two values given equal to the work. So ito yung formula niya. Okay? So papasok tayo ngayon sa example number 4. Ako, medyo mahaba-habang example to. So the space probe na tinawag na Deep Space One na nilaunch noong October 24, 1998. So, 3 taon pa lang ako niyan. And it's used a type of engine called the Ion Repulsion Drive. So, an ion repulsion drive generates only a weak force or thrust, but can do so for long period of time using small amount of fuel. Suppose that the probe which a mass of 474 kilogram, it's traveling at initial speed of 275 meters per second, and no force action except the 5.6 times 10 raised to 2 Newton thrust of its engine. So the external force F is directly parallel to the displacement S, which has a magnitude of 2.42 times 10 raised to 9 power meter, no? Makikita natin dito sa figure na to. So determine the final speed of the probe assuming its mass remain nearly constant. Okay, paano natin i-approach yan? Aha. So, kung madedetermine natin yung final kinetic energy ng space probe na to, madedetermine natin yung final speed. No? Since yung kinetic energy natin is related to the mass and speed according to the equation na kanina, and the mass of the probe is known, alam natin yung mass ng probe eh. So, pwede nating gamitin yung work energy theorem na work is equal to final kinetic energy minus initial kinetic energy, no? So along with the definition of work and find kinetic energy. Ayun. So, paano? So, step 1, hanapin natin yung kinetic energy, no? So, an object of mass m and speed of v has a kinetic energy given by the equation na Ke, kinetic energy equals to 1/2 mv squared. No? So, using the subscript f to denote the final kinetic energy, the final speed of the prod. So, pwede nating sabihin na final kinetic energy equals to 1/2 mass, yung constant yung mass, no? Final, bakit kasi ganyan yung pinaginagamit ko? Maganda yung B dyan eh. Pag ano, no? Final square. Pwede nating sabihin ganun, no? So, pwede nating isolve dito yung B, yung final velocity, no? So, kapag ito, ibinaba ko, tapos in-square ko, oo, pwede. So, ito muna, no? Tanggalin muna natin itong 1/2 m. So, yung 1/2, pag nilipat natin sa kabila, tataas yan. So, magiging 2, magiging 2 multiply by kinetic energy na final, no? Over the mass. Eh, may square yan. Square natin both side. Ang lalabas dyan is the final. Bakit na naman binaganyan ginamit ko? Ay, wala na palang square, no? Ayan. Ayun! Okay. So, step 2. Gamitan natin ng work energy theorem. So, the work energy theorem relates the final kinetic energy na Kf, itong Kf, Kef na to, of the probe to the initial kinetic energy na K is 0. So, in the work W by the force of the engine, so, according dun sa equation na W is equal to Ke final minus K E 0, pwede nating isolve ngayon yung KF, KEF, okay? So, galing dito, So, galing dyan, kunin natin yung kinetic energy na final, magiging work plus kinetic energy initial. Ayun. So, pwede natin itong gawin na yung formula na KE. So, pwede natin itong gawing W is plus 1/2 M B initial square. 'Di ba? Tama. And pwede natin i-substitute 'to papunta dito. No? Yes, pwede. So, ang lalabas ngayon, pag sinubstitute ko yan is magiging square root, kasi mahaba, 2, tapos W plus 1/2 M B0 square over M. Ayun. Okay? And yung W na to is pwede nating sabihin na 'di ba yung W na may formula tayo ng W na force cosine theta. Pwede nating ipasok yan dito. So, ang mangyayari, Nakakahilo na ba, guys? Square root 2 magiging F cosine theta plus 1/2 mb squared na initial over m. Okay? So, gamit ang formula na to, wait guys, kulang ng S dito. May S pala yan, di ba? So, gamit ang formula na to, pwede na tayong mag-direct substitution. Okay? Okay, square root muna tayo. 2. Ano yung F natin? Yung force? Galing dun sa problem. Tingnan natin yung problem. Force act 5.6 times 10 raised to negative 2. Tama ba? Oo. 5.6 times 10 raised to negative 2. Okay? Tapos may cosine theta or 0. Kasi pag ganun lang siya. Pag ganun lang siya. Okay? Multiply natin ng S. Ano yung S natin? Yung S is 2.42 times 10 raised to 9. Okay? Ito pa lang tayo. Plus. Tama ba? Wala. Wala ditong ano. Tanggalin natin. Plus 1/2. Ano yung mass natin? 47. 474 kilogram. Tanggalin natin unit para pure numbers. Okay. Tapos, initial velocity natin, 275 meters per second. Over mass na 474. Mahaba-habang kalkyuhan to. Okay. Calculator check. Square root 474. Okay. 2. Okay. 5.6 times 10 raised to 2 cosine 0 was 2.42 times 10 raised to 9. Tama. Plus 0.5 na lang para madali. 474 275. Syntax error. Kulang. Parang may kulang tayo. Double check. Double check ko lang ha. Guys, alam ko na yung kulang. Square yun, di ba? Hindi ako nagkakamali. Square to. Kailangan naka-square din to. Okay. So, pasok tayo dito. Square to. Ayun! Lumabas na ang final answer. Final answer natin is 804.63 meters per second. Approximately 805 meters per second. And this is our final answer. Yun! Jackpot! Okay. Nakuha din natin yung mahaba-habang solution na yun. Okay, example number 5. So, downhill. Downhill skiing. Skiing yung yellow ata to, no? Ginagamit sa yung yellow, yung nag-slide. So, a 58 kilogram skier is coasting down a 25 degree slope na makikita natin na nasa figure below, no? Dito sa A. Near a top of the slope, her speed is 3.6 meters per second. So she accelerates down the slope because of the gravitational force. Even though a kinetic frictional force of magnitude of 71 Newton opposes her motion. Okay? Ignoring the air resistance, determine the speed at a point that displays of 7 meter downhill. So, meron tayong iba't ibang forces dito, no? Kung mapapansin natin. Meron tayong normal force or Fn. Meron tayong Fk na for fractional. Then, yung bigat nung babaeng nag-ski na 58 kilogram. No? So, the skier's speed at the point of 57 meter downhill. Ito yung tinatawag niya final speed. Depends on her final kinetic energy. So, according to the work energy theorem, her final kinetic energy is related to her initial kinetic energy. So, which we can calculate directly and the work done by the net external force that acts on her. So, the work can be evaluated directly from its definition. Okay. Balik tayo kay Encodo. So, this is problem number 5. Tama ba? Problem number 5. Okay, work energy theorem muna tayo, no? K if final is equal to 1 half m b square na initial plus w. Okay? And pwede nating, tama ba? Teka. Tama. Yung w na to is pwede nating gawing cosine. So, yung ano, m, yung w na yan is pwedeng f, summation of f, cosine theta multiply by s. Tama? Tama ba? Mhm. Pwede. Tapos, itong summation of F na to, galing dun sa figure, yung force, no? Tingnan natin ulit yung figure. Ayun, no? mg cosine. Yung force, mg cosine 25. Okay? Tapos bawasan na natin siya ng F. Okay, yung summation forces kasi, dalawa lang naman to, di ba? Ang summation forces natin dito. Yung F, Fx. Tama. Fk, yung frictional. Saka yung X component ng mg. So, para makuha natin yung X component ng mg, palitan lang natin to ng sign. Right? Okay. So, balik tayo yung kudo. Dito tayo. Summation of forces natin is pwedeng force K, no? Minus. Bakit minus? Ganito yan. Yung Fk kasi, or yung frictional is papunta sa right or sa negative x. Yung ano naman, yung x component ng mg is positive, papuntang positive. So, magka-baliktaran sila. Kaya minus. Okay? So, magiging, mali, anuin muna natin to. Doon muna tayo sa positive side. Okay? So, paano natin makuha yung x component ng mg? Kuha natin yung sign. 25 degrees minus fk. Ayun. So, ano yung natin? Yung bigat nung scalar. So, 358, no? Sine 25 minus 71. Okay, calculator muna tayo. Di ko kayang i-mental math yan. 58 sine 25 minus 71. Lalabas dito, oy, teka, mas lang to. Mo-multiply pa natin dito ng gravitational 9.81. Limutan ko. Ayan. So, tumataginting na 169.46, no? Newton. Or approximately na lang natin 170 Newton. Okay. So, meron na tayo nun. Summation of F. Okay? Tapos, KEF to, no? Kasi di ba meron tayo kanina na nakuha na formula na B final? Plus 2 KEF over M. Pasok natin to ulit doon. So, yung magiging B final natin is equal to square root of 2 multiply by ito, 1/2. Ano natin? Ganyan, di ba? Divided by M. So, pasok na natin dyan. Okay? Pasok na natin dyan. 2. So, 1/2, no? Ano yung mass? 58. Ayan. What is the initial velocity? 3.6 square plus summation of F. Yung kanina 170. Cosine theta. 0 degrees. Multiply natin ito ng S na 57. So, over the mass ulit, 58. Lalabas dito, calculator check. Ang luwas akin dito is 18.97 or approximately 19 meters per second. This is the final answer. Yun. So, ito naman is conceptual problem, no? Concept lang to. So, makikita natin dito sa figure na to, yung illustrate a satellite moving about the Earth in a circular orbit and an elliptical orbit. So, the only external force that acts on the satellite is the gravitational force in which orbit does the kinetic energy of satellite changes. Changes ng yung circular saka elliptical orbit. So, sabi niya dito, in which daw does the kinetic energy of the satellite change? Circular orbit or elliptical orbit? So, ang tamang sagot dito talaga is A. Bakit? Kasi for the circular orbit, yung figure natin na nasa A, the gravitational force F does not no work on the satellite since the force F is perpendicular to the instantaneous displacement S of all times. Okay? Thus, the work done by the net force is zero and according to the work energy theorem, no, the kinetic energy of the satellite remains the same everywhere in the orbit. So, yun. So, puputulin ko man dito, no? Kasi 1 hour na yung video. And, lista nyo lahat ng ano, katulad nung ulit ng dati, lista nyo lahat ng katanungan nyo. Pwede nyo isend sa GC or i-discuss natin sa synchronous. Okay? So, start tayo mamaya sa gravitational potential energy. Okay?